Hey, welcome back to Engineer's Workshop. So, what looks different? My elbow rest that I've had here for months, and in the introduction of many videos, is finally prepped, painted, and ready to install. This is the Trolley Beam. If you recall, I have a Yale 3-ton hoist, and I have a 3-ton trolley. This is going up on the underside of one of my building rafter sets, and it's going to enable me to unload equipment from trailers or trucks, move it back and forth. This has been a long time coming. Before we hang this beam, let me show you real quick a little bit of the prep work that was involved in getting it from its original state to where you see it now. If you recall, this was, laying in a field. We unloaded it. We had to clean off chunks of weldments that were diagonal braces and such. So a lot of grinding, a lot of hot forging work to straighten out issues with the bottom flange, but we got it to this point, and let's hang this beam. If you recall, in the last video, we had to heat and hammer flatten a big bump that was in the bottom flange of the beam. So we'll pick up where we left off there and continue with the prep. This is just taking forever. So I've got some new grinding wheels. I'm going to try out Sigma Green 36 grit. And these have a zirconia grit as a part of it. And then I've got a big one that also has ceramic CGW abrasives, G3 ceramic. So we'll give this a try. My goal is I'm trying to remove metal quickly. I said, give me the discs that remove the most amount of metal. I don't care if they, if the disc wears away. I want to remove the most amount of metal quickly. So we'll see how they do. I'm going to start here where I wasn't making much progress. So this is another wide flange beam that was welded perpendicular, and when I get to where all of the base metal is being removed, you'll see these areas glow. I probably have more video footage from preparing this trolley beam than any other video I've done, but just looking at me grind and cut is not something that most people want to see. Wow, that's impressive. I don't know what real time that was, maybe 4 minutes. This side took me like 30 minutes to get the same result. So these are keepers, like $4 or $5. These outer pockets are pretty crusty. When the beam was sitting out in the field for God knows how long, water had collected inside of these up to this point. It's not to a point where it's affecting the structural integrity of it. Some pitting along this area here, and this is the section I believe that we hammer straightened or forged on to eliminate a big bend that was in the bottom flange. Get that pretty straight. So we're going to just clean this scale off of here and we'll paint everything up. Hopefully that'll be the last of the corrosion. Trying out a twist wire wheel. This little guy gets into the corners really well. So from a point where the edge of this block is vertical, I'm just scribing a line with a carbide scriber. Just use a little Sharpie for my marks. And we're not building a space shuttle, so we're using a framing square. Now I've got to step back from this line. Let me look up the number. It's 17 30 seconds back from this point. so just a hair over a ½ inch. So when I lay my lateral supports on that line, butted up here, and on that line, I'm establishing an angle from vertical that is exactly half of the difference between the pitch of my rafters and a horizontal, and that lets the upper stop block lay against this side of the lateral support, and I have enough room in these holes for the threaded rod. Let me show you that, how that's going to work. This is a 1/2 20 high tensile strength rod, threaded rod. It's like a grade 8 bolt, and this is a washer pair with a spherical seat. They mate, and then as they slide back and forth, they can accommodate a little bit of misalignment. So that's going to go on here. Actually, I think we're going to want the seat like that. And then high strength grade 8 nuts. And those come up from the underside. So instead of being at a right angle, they're able to lay back at an angle to match this lateral support, and the spherical seat on the washer just swivels to accommodate that. And I've put clearance in the bolt holes so that they have more than enough angular clearance that they won't bear and dig into the corners of the bolt holes. So I've got my gravity clamp holding the angle down. I'm an offset an 1/8 inch from the inner edge of the heavy block, and this is kicked at it's about a 2.5 degree angle. I'm going to get a little bit of heat into these components. All of the welds on these heavy components required significant amount of preheat, because the little MIG welder that I'm using is really only good up to maybe 1/4 inch material. And the angles, the 2x2 angles were 1/4 inch thick, but those bottom plates 1 inch thick, the flanges of the beam were more like 3/8 thick. All of that required significant preheat, and then multiple passes, 3 passes, to get what I considered a halfway decent weld on those members. To line up the second part of this, I just need to get these faces flush, and I've got the offset here, so as long as I'm tucked up against the stop block and I got these faces flush, that will allow a bolt to pass through these 2 holes. The gravity clamping plate that I referred to in a couple of these shots is a railroad tie plate, and they're just amazingly heavy. I think they're cast steel, and I think that thing must weigh 30 or 40 pounds. The thickness varies, but it's no thinner than about a ½ inch at the edges, and it's more like 3/4 thick where underneath where the rail bears, and it does a good job of holding steel components in place. Well, after a little bit of grinding, and by a little bit I mean 2 solid hours, I've got the two remnants of those center gussets cleaned up almost to where they're not visible. So finishing touches on that, vacuum up all of the steel, and then I'll start prepping this for paint.
The absolute champion disc for removing metal turned out to be a 40 grit flap disc, which is a little bit surprising, not the zirconia grinding disc. So the flap disc, 40 grit, that thing just hogged metal off of where we had the intermediate gussets on this beam, and it did a better job at flattening for where the trolley wheels ride than the grinding disc alone. Although the beam was primed initially, it did have a lot of areas that had rusted and the prime coating was gone. So I went over the entire surface of the beam with a big cup wheel that fit the 8-inch grinder. It was about, 6 or 7 inches in diameter, and the cup wheel I could lay flat on the flanges and on the web and just cover a lot of surface area to get the chalkiness and the loose primer and surface rust off of the beam. So I kept just going over every inch of that beam with the big wheel, except the corners where I had to go with the smaller little die grinder type end wheel.
Here's the arrangement on one end of the trolley beam finished up, and just a quick coat of paint on it. I'm pretty pleased with the way the welds came out on this. I was pushing my little MIG welder for the capacity, but I preheated everything well. And based on this, instead of bolting the top center carrier in place, I intended to through bolt this. I'm going to go ahead and weld this. I have the holes so I can just match drill through and add fasteners later if necessary, but I really think based on the weld quality that I see that this should be fine welded in place. And recall that the tension rods on this are not going to be pre-tensioned. They're just going to be run up to touch, so that as this beam begins to deflect, that load is going to transfer up to the apex of the building frame, and the building frame will help carry that load.
Finally, the day came to get this beam painted. I never thought I'd get there. I initially thought I would go with a complete brush coat, like a stripe coat, prime coat, finish coat, but the quality of that brush coat that went on was not great. There are runs and drips, but they're in the primer, I swear. The primer just was a sloppy job, and the beam was upside down when it was primed, so the drips run uphill. We followed up with about 10 or 12 cans, spray bomb cans of sunburst yellow from Rust-Oleum, which was a nice color, a little bit darker yellow than a true safety yellow, but it just has a nice look to it.
But we got the trolley resized to fit the beam. Got to tighten it in place with the impact gun, and then do a little bit of touch-up painting here and there on the beam.
The first steps in getting this beam up into its final resting place was to get the Yale 3-ton trolley up high enough to be able to lift the beam. So we're using 1-ton come along, and we had to use a piece of conduit and the sway bracing in the building to lift the Yale 3-ton hoist, which weighs right around 100 pounds, and get that up high enough into the apex there where we could use the Yale 3-ton hoist to lift the beam. So we're getting it up high enough, and I have a load binder chain up there kind of tied around the purlins, and we've got it looped down under the rafter. And my son Brennan is just getting it run up high enough to get the load binder chain run through the upper hook of the Yale 3-ton hoist, and then get that chain up as snug as possible. We ran into a little bit of an issue that I didn't foresee as I ran the hook up to the top of the trolley. There was actually a half twist in the chain, and I wasn't able to get the beam up quite as high as I would have liked. I lost my video footage of getting the beam hooked up to the boom pole of the tractor and driving it around to the building, which is probably for the better because it wasn't pretty. The inertia of that beam just jerked me left and right as I was trying to hold it in place and oriented. But the next 12 feet of lift went really nice, just hand over hand, get the beam oriented with a tag line, and then once it was up close enough, just get those lateral braces to index in place.
Looks like that's all the higher I'm going to be able to get with the hoist. What was not apparent when it was all the way down was the hook has put a half twist in the chain, and I need to flop the hook over against itself. So I can't wind it any closer to the spool without the edges of the links starting to bind on the drum. But I am within the range of getting my tie rods in place. So I'm gonna get the tie rods set up loosely, and that will hold each end of the beam up. And from that point, I can use ratchet straps on either end to bring the beam up to its final point. It's engaged on the left end, so it can't drop down. I'm hoping I can get the tie rods started on the right first.
The initial length of the tie rods is 6 feet, so it was plenty long enough to reach through the bottom support plate and the upper plate there. The not so fun part was running a half 20 nut up a fine thread rod every time I incremented the beam upwards.
The left end of the beam is secured by its threaded rods. And now we're adding 2 to the right side. Once these 2 threaded rods are in place, the beam can't fall. So we can proceed to inch it up left and right with the ratchet straps. A lot of filth on top of this building structural member. Surprising how warm it is up here against this ceiling, even on a relatively cool day. The ratchet strap just wasn't cutting it. It was only getting me a half inch at a time. So I cut a piece of log that was wide enough to straddle the beam, and then setting this over top of the beam, I can pass the cable from the come along over this and get 4 to 5 inches of movement at a time. Been working back and forth, getting about 4 inches, 5 inches at a time, and I have both of the lateral supports, engaged with the upper beam, and as I'm coming up, the beam is a little bit too far that way. So I'm using a trick borrowed from my 1970 Bel Air. Some of you might be aware of a suspension piece called a panhard rod or panhard bar. It's a lateral link that's attached to the frame at one side and to the rear axle at the other. And it provides lateral stability for the rear suspension. So it swings on an arc. And what I've got here is I've got a strap hooked up. So this is a panhard strap. And what I'm going to do is scoot the beam towards me until I'm basically underneath my reference lines. And it's basically just free swinging. And then I'm going to continue the lift. And that will keep things going up steadily towards this thing. I think maybe while I'm over here, I'll give one more set of cranks to this side and run the nuts up. Doesn't sound good, but really it's just the cable equalizing itself. And I'm only about 8 inches from being all the way up. Lifting with a piece of 1/2 inch heavy conduit, and the beam is about 700 pounds, so 350 pounds on either end. Really not a lot of weight. And I've got a 1-ton come along, and I've got my wood blocks up here that act as a kind of a half-moon pulley. Even with my ratchet strap trying to keep the beam centered left to right, I still had a little bit of wandering, left and right relative to the exact placement that I wanted it. It ended up in the right place, but I had to do some finessing at the very end. And when I checked the beam for level, it was just dead on level at the top, so I was pleased with that. Touching here, looks like I'm pretty close to my line. I'm going to run my nuts up to keep it from dropping, and I'm going to put a half 13 by 8 inch bolt across the top of the lateral stabilizers. That's just an additional belt and suspender so that it can't fall. The center tie rods were just basically in place, not tightened, but they prevent the beam from drooping in the middle. They will start to share the load if the beam deflects. The next step was to cut the excess tie rods off and then prep them to make the secondary set of tie rods. Just need to clean off the threads. Getting down to the final steps here, which is putting in the last 2 tie rods and then getting everything torqued to the correct tightness. So my logic on this, I have a 3-ton trolley, 6,000 pounds. I want to have a 2-to-1 safety factor on my tie rods, and I want them so that if the trolley is all the way over at one end, that they're tensioned collectively to twice the potential load that the trolley can deliver. So 3,000 pounds of tension in each tie rod times 4 gives me 12,000 pounds of upward preload against the beam. It would take that much vertical load in order to overcome the clamp of the tie rods. That's how bolts and things like tie rods hold things in place. They're essentially springs. So first thing I'm going to do is attach a level, which unfortunately is going to be on the back side of this. You won't be able to see it, but I want to be able to watch the sides of the beam to make sure they're staying level as I tighten up the tie rods. And 30 foot-pounds is what gives me the correct torque in these tie rods, or tension. Okay. Well, I don't think that's coming down. I will check the torque maybe after 6 months or so through the winter and see if anything has relaxed. I doubt that it will. Now we're going to try to test it with a couple of loads. I know a TDI engine isn't much of a load, but it's the first thing that my son needed to work with, get on the engine stand. So this just moves super easy. And we've got very good control.
So very happy with this. This will enable me to unload equipment, disassemble and reassemble the lathe. Can't be happier that this is done. I hope you enjoyed it. Next time I think we'll go back on the Skinner steam engine, but needed to get this up because I've got something coming that I think you'll really enjoy. Catch you next time on Engineer's Workshop.